Today we'll be starting the second module of network theory. Content of the module: Thevenin's theorem, Norton's theorem, superposition theorem, reciprocity theorem, and maximum power transfer theorem. And in this session I'll be explaining to you Thevenin's theorem. Thevenin's theorem states that any two terminals of a network can be replaced by an equivalent voltage source and an equivalent series resistance. These are the two terminals of the network. This is the network and this is the load resistance RL. This network, the two terminals of the network can be replaced by an equivalent voltage source and an equivalent resistance. The equivalent voltage source is VTH, which is called the Thevenin's voltage, and RTH is the Thevenin's resistance. Okay, and the voltage source is the voltage across the two terminals with load, if any, removed. That is, the VTH, the voltage source, the Thevenin's voltage, is the voltage across the two terminals with the load resistance removed. This is the load resistance, and after removing the load resistance, we find the voltage across this network, and that is the Thevenin's voltage. The series resistance is the resistance of the network measured between the two terminals with the load removed and constant voltage sources being replaced by its internal resistance and constant current sources being replaced by infinite resistance. That is, we can find RTH by removing the load resistance and then seeing from this direction we can find the effective resistance, but by shorting the voltage sources and by opening the current sources. This is the explanation of the Thevenin's theorem. Okay, so now we'll see an example. This is the network, a sample network with a load resistance RL, and this is the network portion. Okay, so now we are going to find the Thevenin equivalent for the terminals A and B. So initially we have to remove the load resistance RL, and it is shown in this figure, and the voltage across these two terminals is the VTH. So now how to find VTH? VTH is the voltage across these two terminals. So we'll know that the current flows like this. There is no current in this branch. It's open circuited here. Therefore, there is no current in this branch. Therefore, we can find the voltage across this resistor, and it will give the VTH. Therefore, VTH is equal to, we can use the voltage division rule here, total voltage into resistance of the same branch divided by sum of the resistance. That is, if there are two voltage resistance in series, the voltage drop across a particular resistance is given by the total voltage into resistance of the same branch divided by sum of the resistance, and that voltage division rule is used here, and thus we got this equation. So for the equivalent circuit, we have got the VTH, and now we have to find, first step was to find the VTH. The second step is to find the RTH. So for RTH also we have to remove the load resistance, and the voltage sources are short circuited, and if there were current sources, it should have been open circuited. Here there are no current sources, so there is no open circuit. So here the load is removed, and we have to find effective resistance from looking from this direction. That is R1 parallel R2 plus R3. That is given here. So now we have got the VTH and RTH. So we have to put these two in series, and we have to replace this load resistance RL. And this is the Thevenin equivalent circuit. Okay. So now in some questions it will be asked like find the current through the load resistance RL. At that time we can use IL is equal to, this is the, we can draw the IL in this direction. So we can find the current through RL as IL is equal to VTH total voltage by total resistance. Thus we have found the current through the load resistance. So now we have seen the brief idea of how to find the Thevenin equivalent circuit. So now we'll be moving on to its details. We have got three types of problems in Thevenin's theorem, that is with independent sources only. Second type with both independent and dependent sources. And the third type, dependent sources only. So I'll show you examples of the three types. So first we'll be seeing the example of problems dealing with independent sources only. The question is, find the current through the 2 ohm resistor. So how can we solve it by using Thevenin's theorem? That is, we have to find the Thevenin equivalent of the circuit. That is, we have to find the VTH and RTH by removing 2 ohm, and then finally we have to draw the circuit. We have to draw the circuit of the equivalent circuit and then replace the 2 ohm here and then find the current through the 2 ohm resistor. So now we are going to find the VTH and RTH. So to find the VTH, initially we have to remove the load resistor. That is the first step. First step is to remove load resistor. So we can draw the circuit. It's 40 volt, 5 ohm, 20 volt, 10 ohm and 10 volt. So we have removed the 2 ohm resistor. So now the voltage across these two terminals is VTH. So I'll draw it like this. VTH. Okay. So we have got the 10 volt here, but to know the voltage here we should know the current through this resistor. So we can find the current through this resistor by using KVL. That is, we can write 40 minus 5I, let the current be I, minus 20 minus 10I is equal to 0. So we will get it as minus 15I is equal to minus 20. Therefore, I is equal to 20 by 15, that is equal to 1.33 ampere. So now we have got the current through the 10 ohm and it is flowing downwards. So we can mark the direction of the current like this, plus, minus. So 1.33 ampere is flowing downwards. So we can take the path from VTH to downwards. VTH minus 10I minus 10 is equal to 0. So VTH minus 10 into 1.33 minus 10 is equal to 0. Therefore, VTH is equal to 13.3 plus 10, that is equal to 23.3 volt is our VTH. Okay, so now we have to calculate RTH. So now we will go for RTH. So the first step for RTH is also to remove the 2 ohm resistor, and also we have to short circuit the voltage sources. So we can draw the circuit like okay. Therefore, the equivalent resistance by looking through this branch, this terminal, we will get it as 10 parallel 5. That is 10 into 5 by 10 plus 5, which is equal to 3.33. So now we have got RTH also. So next we can draw the Thevenin equivalent circuit. This is 23.3 volt and it is 3.33 ohm resistor. Okay. So now we have got the Thevenin equivalent across the 2 terminals. So now we can replace the load resistor, that is 2 ohm, and now we can find the current through 2 ohm. That is IL is equal to, for such a circuit we can find the current by total voltage by total resistance. Here the total voltage is 23.3 and the total resistance is 3.33 plus 2, that is equal to 4.37 ampere. So thus now we have found the current through the resistor, 2 ohm resistor. Okay, thank you. And now in the next session we will be dealing with dealing with a problem on dependent and independent sources. Thank you.